back to AI Aotearoa. So I just had to jump on here because they just rolled out WAN 2.2 and I had to play with it yesterday, and I gotta say I was pretty impressed. So just firing up ComfyUI now. So if we go into workflow now, go into Browse Templates, we go into Video, and we can see the new WAN 2.2 models are right here. I haven't played with the first two because they require a lot of RAM. I've started with the WAN 2.2 5B video generation version, which is a lot smaller. So let's just fire that up. So here it is set to default. Currently image to video is not enabled. You can see it here just blanked out. We've got a prompt, low contrast, and a retro 1970s style subway station. A street musician plays in dim colours and rough textures. He wears an old jacket, playing guitar with focus. Commuters hurry by and a small crowd gathers to listen. The camera slowly moves right, capturing the blend of music and city noise with old subway signs and mottled walls in the background. So that's the prompt. Here's the first things to take note of. When you first fire this up, it should ask you to automatically download WAN 2.2 text and image to video 5B FP16 safe tensors. That's the model. Hopefully you will have already downloaded and installed the clip model, which is the UMT5 XXL FP8 E4M3 FN scale safe tensor. Type WAN, that's fine. I'd add a weight type, so don't use the FP8 EFM3 FN fast, use the standard because that runs with the 5B model. The other version, the fast model, the fast weight type, that does work with the larger models, but not with this one. So especially if you only have a 30 series RTX NVIDIA video card, which is what I have. It's a very slow card, it's only got 12 gigabytes of RAM, so I just wanted to show you what it's capable of doing with just that much. So we're going to drop the resolution down just to make this faster. If you also have to install the WAN 2.2 VAE safe tensor. So all the links to download all of these are here in the model links. So download these and then put them into the corresponding folders, which you can see here. And models, diffusion models, put your WAN 2.2 model. And text encoders, put the UMT5 XXL scaled safe tensor. And in VAE, put the WAN 2.2 VAE safe tensor. And then you should be up and running and ready to go. So, but one thing we're going to do is we're going to change the resolution to the Midjourney resolution, which is 832 by 464. We're going to leave the length at 121 seconds, sorry. So we're going to leave the length at 121 frames, which is 5 seconds. Steps, we're going to leave at 20. But this is probably the thing that we're going to change to initially get the quality to improve. And we're good to go. So we're just going to run this. But before I run this, I'm going to get my stopwatch and I'm going to time it. And start the render. Control Enter. And start the stopwatch. So initially, it's going to take a little while just to load these different safe tensor files. Currently it's loading the VAE. Once all of these three models are loaded, then we shouldn't have any problem with generating a lot faster. But I'm just going to show you initially how long it takes, at least with a 12 gigabyte GPU, to load these different models and run for the first time. Okay, so now it's starting to load clip. It's taking quite a while on this computer. Yeah, we're 4 minutes into the load, and now it's finally loading the WAN 2.2 model, so it's going to take a while to load as well. So that's how slow it was just loading clip and loading VAE on this 12 gigabyte computer with RTX 3060 NVIDIA card. Alright, so we've hit the 10-minute mark. Actually, it's just clicked over to 11 minutes, and now we're in K-Sampler. Given that this is 121 frames, so this is a 5-second clip, so this is at the high end of anything I've really tried when it comes to rendering video generations in ComfyUI. Now with a larger VRAM and a faster GPU, obviously you're going to be able to increase your length, you're going to be able to increase your resolution. Okay, we're at 90% now. So this has taken quite some time. I've heard that this takes seconds on a 50 series RTX NVIDIA card. We don't have a budget for a 5,000 New Zealand dollars video card. That would be more than the value of my car. There we go. So K-Sampler is finished. Now we're in the VAE decode segment right here. So really this generation is coming into land now. Goes from here into the create video and save video. Here I'd change this. I'll change this now, it won't matter for this generation, but or for the next. So normally I'd change this to MP4 and I'd change the codec to H.264. It seems like that's all the options they give you anyhow with the save video option. It's at 24 frames per second. That's how I know that 121 is approximately 5 seconds. So this next generation that we do, the follow-up generation, we're just going to use 72 frames. We're going to do a 3-second render. It should take a lot less time now that the models are all loaded in, and if it's a lot shorter. You can see up here the VRAM is maxing out, the GPU is maxing out. Now we're in the save video and all of these are dropping off. So now it's finished. This is the video. Let's have a look at it. Okay, so that's not bad, right? So some of their faces aren't very detailed. He looks pretty good actually, given how small the video is. We've got the usual suspects. The text is gobbledygook. All of this kind of signage is kind of rubbish. And there's a kind of funky guitar here in the background. Doesn't quite look like a normal guitar. But we're going to change the length now to 72 frames. You probably see that though I changed this to 464, it's defaulted to 480. If I try and change it to 464, it's going to stay at 480. So that just seems to be a glitch with ComfyUI. Same with the length. I said 72, it says 73. Put in 72, go OK, stay 73. So 73 is close enough to 3 seconds. So now we're going to do another run, knowing that all of these are loaded. So it's going to jump straight into clip and then start processing almost immediately. Alright, so I'm going to reset my stopwatch and I'll start this again. Control Enter. And as you can see, it's whipped through those so fast that you didn't even see it happening. It's gone straight to K-Sampler, straight to the fun part. But it's doing 73 frames, exactly the same prompt. So let's see how long this takes to generate. Alright, so it's almost finished, this generation. K-Sampler's at 95% at the moment. It's just about to go into the final stage, the VAE decode and then create video. So far it's been about 5 minutes. Here we go into the final. So that's about half the time that it took to generate the last video. The next step is to try and up the steps. So after this finishes generating, we have a look at the results. We're going to try and up the steps, which is just here. Steps is the amount of passes it takes to generate each of those images as it goes into sequence. So the more steps, generally the higher quality. The other thing is, you may be wondering why, if you have a 3060 RTX NVIDIA GPU with 12 gigabytes of RAM on it, why it's faster for you to generate. And that's because obviously I'm capturing my video screen in the background using the same computer as I'm operating and generating this video. So that capturing process is going to take up a certain amount of the VRAM and slow the process down quite a bit. If I don't have the capture process going, this is a lot faster. We're just about at the 7-minute mark. So this actually did take approximately, there we go. So that's about as long as you'd imagine comparatively percentage wise, about 7 minutes to create a 3-second video, about 10 minutes to create a 5-second video. That makes sense. So what we're going to do is we're going to pump this up to 50 steps, and we're going to run it again just so I can show you the difference in quality. The other way to increase the quality of the final resolution video generation is to increase the resolution of the width and height, which will be the final thing we do. But Control Enter, we'll start this process again. I'm going to go off and do something else, but I'll reset this and start again just so we get an idea about how that increase in steps also increases the render time. Alright, we're at 92% in the K sampler at about the 10-minute mark. Alright, the generation is coming into land at about the 12-minute mark. We're in the VAE decode just before create video. So it's finished rendering. So this is the 50 steps at 73 frames, so about 3 seconds there, at 832 pixels wide by 480 in height. So aside from this weird secondary action here with the flashing lights, it's hard to tell if the quality is much better than the first generation. But one thing that will definitely increase the quality is to increase the size. So for this next, and that took quite a while, so that took about 16 minutes to complete that generation. So what we're going to do is we're going to drop these steps back down to 30 instead of 20 and 50. So happy middle ground, 30. But we're going to increase the length by 100 to 121 frames. So the length is going to be 121 frames, the full length of the video that we tried initially. And the resolution will make 1280 by 720. So 736 it says, but anyhow, close enough. So basically, with every other single model that I've tried, I haven't really got up to 121 frames before it said it's out of memory. So this is a real test. So let's see how long it's going to take for us to render at this 720p resolution for a 5-second video with 30 steps on a NVIDIA 3060 GPU with a measly 12 gigabytes of VRAM. Alright, so it took over an hour to finish the render, the generation, but there we go, 5 seconds at 720p. Just looking at the first still frame, the quality seems pretty good. We'll play it back. So this is at 30 steps. The face is still a bit murky. Motion looks good. Secondary motion looks alright. Not sure what this person is doing here. Whether they've got a pole going up their back or whatever. But the foreground elements are working well, and our guitarist is working well. So that was pretty successful, and that was really pushing the limits for what my computer can do. So that again took just over an hour to complete that generation. So now let's go to the image section. We'll go Control B and unfreeze this so we can upload an image. Let's grab an image that we can try and animate. Let's use this demon character. And the other thing you can do is you can actually add a LoRa. So if you add, there it is, load LoRa model only, and maybe I choose decay, so we could make this character decay. And to add the LoRa is really simple. You can see it's going, model's going to the sampler here. So instead, attach this to model input and attach model input to LoRa model input. So now let's just, we'll create our prompt, copy and paste it across, because that's already got the decay in here. There's the decay prompt for the LoRa. So we're good to go. So I'm going to stop capturing and I'm going to go off and have some food. And I'll let you know how long it takes to generate this. So this is image to video generation, at 720p or just over 720p at 5 seconds. So this is basically already excelling what Midjourney is providing, but I think their motion models or their steps must be higher because they don't get so much of that sort of blending face. But again, this has been done all locally, which is pretty impressive. So let's see how it does with a image to start off with. Okay, that was highly successful. We got our full image, 5 seconds, and it added a little bit of decay in there with the decay LoRa in the string. Here in the pipeline, in between model and model sampler. So you can adjust the strength models for the LoRa and here for the model itself before it gets into the sampler. And that will change your final results quite a bit depending on how it's adjusted. Like, just experiment to figure out what works best for you. Okay, so here's the image in Midjourney. Let's add the same prompt, but we can take away some of these prompt words, these trigger words, because they're not going to work for Midjourney. A lot of this is probably not going to work for Midjourney. Some of these words may be triggering words. We'll just see how we go. And it's a melting demon, not a melting cyborg. Starting, okay, that's a good sign. So it looks like it's going to do it. So we'll see how this compares with our last generation. So obviously it rendered a lot faster. It rendered 4 of them, and probably if we've got a winner at all, it's probably this one, either this one or this one, even though the blood looks kind of fake. So let's just download this one and we can compare at least the resolution of the image in comparison to our ComfyUI generation. And that's it for now. So basically we're just going to put a pin in this because now I've got to test the GGUF workflows. They've just rolled out. Somebody in the community has figured out and created these different models based off the WAN 2.2 model. So these will be optimized and should run a lot better on lower VRAM. So I'll let you know how that goes. Until then, if you found this video useful, give us a like, subscribe, and hit the notification bell for the next video that's coming soon. Okay, bye for now.